while you're here, try to make sure that you're not just listening to the talks, but you're making the most out of the hallway track, meeting the people, meeting the speakers, meeting the people who are sitting next to you and learning from them. And community is important. And the Valkey community in particular started with a very interesting story when a company decided to close source one of the most loved open source pieces of software. And what happened was Madelyn was, one of the committers, and she got fired because she couldn't tell jokes properly. So she got fired from being able to make commits. And suddenly we thought that Redis was going to be closed source and people have to figure something else out. And Madelyn said, no, not on my watch. And she started this revolution. There's a lot of people that made Valkey into what it is today, but you need that initial spark, you need that initial leadership, and you need the ability to kind of gather all of the forces to come together and create a fork, and not just create the fork and let it kind of die a slow death, but a fork that ignites consistent innovation, consistent sharing of best practices, and consistent improvements in the entire stack. And that's been really, really exciting to see that the product, the open source aspects of Valkey just keeps getting better and better every single day. And when you're thinking about performance, I will warn you that being performance oriented.
By the way, your slides are showing.
Fantastic. I should be good. Does that mean people didn't see the visual of Madelyn saying not on my watch?
I know, that's why I didn't say anything. I didn't want to, I didn't want to make sure.
So that happened. Madelyn got fired. I like saying that. But she said not on my watch, and she kicked off this community. And it's been awesome to see that this fire that got started continues to innovate every single day with every single release. And while we're here to learn about performance, I will warn you, performance is a mindset that doesn't just apply to infrastructure. Once you get hooked on performance, it applies to your organizations and it applies to people as well. And doing performance-oriented things require you to have consistent iteration. This particular event got concocted in a matter of 2 months from us saying, we're going to do this, to an army of amazing speakers saying, yes, we are. And we are going to come in. We're going to go through all the work of, because the people we're speaking are super, super busy, but they went through all the approval process because, trust me, good engineers don't like to do all the paperwork that's required to give talks, but they did that. So thank you for doing that. They got their approvals. They put slides together. They rehearsed their slides, and they got their slides done on time. At least most of them did. But putting it together required a lot of work, background work, especially for some people who are not even here today. So folks like Hannah and Kelsey back in Momento land who couldn't be here today, they put a lot of work in getting everything to be as smooth as it possibly could, getting this awesome venue. And Mike has been working closely with all of the speakers to make sure that the slides are ready to go, that the stories are coherent, and the lessons are being shared in the best possible way. You're going to hear from speakers who have real-world production workloads, large workloads. So many of these people just whip out words like hundreds of millions of QPS or billion QPS as if it's like not a big deal. It is a big deal. And you learn a lot of lessons when you get there. So what we're going to see today, there's 4 kind of categories that I see. To pee or not to pee is a very important question. I'm not talking about a bathroom break. This is the proxy. The big P word is proxy. It's a very controversial, very common question that many of us are reconciling with, whether there should or shouldn't be a proxy behind your caching clusters or in front of your caching clusters. You're going to hear from Kevin, on how Elasticache serverless is running on top of a proxy. You're going to hear from Snap, from Ovase at Snap on their takes on proxy. You're going to see real world lessons in the Valkey ecosystem, the larger ecosystem that spans beyond the actual Valkey software, and the importance of clinical characterization. And with that, I want to share my takes on proxy. And proxy is a very controversial subject. And there's a lot of downsides to adding a proxy into your caching layer. And for me personally, I love bunnies, but I hate hops. An extra hop, if you're trying to build an ultra low latency system, you're trying to hit some 100 or hundreds of microsecond threshold, the last thing you want to do is add one more hop to it. You get to head of line blocking. Thanks, Redis protocol, for not having multiplexing yet, but we have a PR that hopefully will get multiplexing in there. And it's extra infrastructure that is there. So like you could potentially, especially if your proxy is written poorly, you could double the cost, whether it's latency, availability, or dollars. But there's positives as well of proxy. It's an engineering problem. And how do you actually reduce the impact? How do you make benefits of the actual upside of the proxy as well? And some of those optimizations, as you get into clinical characterization, you realize there are things that you can do to make proxies work. Deliberate placement. Are the proxies closely located to the actual cache nodes? Actual caching at the proxy so you can avoid the hop whenever possible. Proxies also reduce the load on your caching server. They can coalesce a lot of requests. When we did a whole bunch of benchmarks on showing 1 million QPS on an 8-core box for Valkey 8.1, we realized that so much of the processing was going to packet processing. And 25% of the processing, if you're doing unpipelined requests, 25% of your CPU, like 2 of the 8 cores were just at 100%, just processing packets. Coalescing requests lets you reclaim those, because then the kernel is doing fewer things. It's just taking those requests and just handing it to Redis. And that reduces the load on your storage nodes as well, as does caching at the proxy. You can abstract federation. And the other thing you can do that I'm most excited about is you can also, if you do the proxy right, you can also replace your HTTP server in many cases by having programmability in the proxy. Now, I know you love Lua scripts, right?
I do love Lua scripts.
Inside of Redis?
I do.
Or inside of Valkey?
Well, I do not like them in Redis, but I love them in Valkey. They cause terrible latency issues, but they're so fun. They can cause your Valkey to blow up.
I have a strong religious belief about not having Lua scripts inside of your storage node. The blast radius is just way too high. But the proxy is programmable. The proxy is somewhat stateless, and it's a much better place to put your logic while still co-located right next to the data without it being able to blow up your storage nodes. Scale exposes all truths. And some of the talks today, you'll learn this firsthand. When people started running Valkey clusters at scale, there's multiple teams here that ran into, well, I can't have more than 500 nodes in my Valkey cluster. It exposed flaws as people started to get into hundreds of nodes of Redis or Valkey. And something that Jacob's been teaching me is that even if you have 2 nodes, when you're trying to relocate or replace 16,384 slots, because that's just how the distributed hash table works, even if you have 2 nodes, even if there's nothing in those entities previously, that causes a lot of tumult and churn inside of your cluster. And these things happen behind the scenes. They impact the customer, but it's just because the slot migration was causing undue load at the server, it was causing redirects at the clients. And this actually got meaningfully better in Valkey 9 with atomic slot migration. So Jacob's going to be talking a lot about that. Sarthak's going to talk about 1 billion. To take that away, but it's about being able to support a 2,000 node cluster. all of the tiny corner cases, all of the bugs, or so many of the bugs that were discovered due to law of large numbers, probability wise, they just show up when you have a 2000 node cluster. And this is another example, like the clustering support inside of the Valkey ecosystem keeps getting better. And one of the fundamental themes that I've seen after the fork is pre-fork reliability was an enterprise feature. So we would have a bunch of things in the open source software that maybe made it go a little bit faster, but anything that had to do with robustness or running it in a mission critical environment was not part of the ecosystem. And with Valkey, if you look at so many of the contributions are around the admin plane, they're around the actual clustering support. They're making the system more robust. And this is the power of open source, where it's not just one company pushing it through so that they can withhold the enterprise features back from you. Small improvements compound, and we see this. Valkey 8.1 allowed us to get to 1 million, like 1.2 million requests per second without pipelining individual requests, each arriving in their own packets on an 8-core Graviton 4 box. But you could not get that performance if you were doing pipeline. Pipelining was really bad in 8.1, 8.2. Valkey 9 improved pipelining meaningfully. And it actually upset me as like as somebody who does benchmarks and writes about them, because it kind of rendered all of my numbers unnecessary. In Valkey 9, we're able to push a 4-core node with 1 million requests per second with ridiculously low latencies, the same ones that you were seeing before, just by pipelining things. And what all that means is, combine multiple requests in the same packet. And, it's like going to Costco. You're not going there to buy like one pack of chewing gum from 7-Eleven and then going back and buying one egg. You're just buying all those things all at once. And that meaningfully improved stability, as did large items optimizations with copy avoidance in Valkey 9. So these are all like features that would previously be considered enterprise. They would be behind a paid wall. And they're not right now, because we're seeing all of these things make it into the ecosystem, and there isn't really anybody incentivized anymore to avoid letting these things into the ecosystem. So much of driving these improvements, whether it's inside the Valkey open source project or if it's inside your own end-to-end stack, it requires you to do clinical characterization. It requires you, and clinical characterization is the opposite of like a marketing blog. It's reproducible data, but clinical characterization is very hard. It is very painful, and you will never have time for it because you didn't clinically characterize your stack. So let me unpack that for you. Understanding the dimensions where your stack struggles, understanding the end users and the characteristics of the workflow and how they expose the various performance dimensions, whether it's memory bandwidth, whether it's network bandwidth, whether it's the storage, whether it's the CPU, whether it's too many brand new connections being made at once. Being able to kind of break the problem and take it from, here's what my end users, because a lot of us are platform team folks, here's the end user that just comes in and says, I just want to run 1 million requests per second. What's the problem? And then you're like, well, but maybe not reschedule 4,000 Kubernetes pods all at once and create like a connection store, right? Like you have to take their requirements. It helps you to work backwards from your customers, but then you have to break them into specific dimensions of your overall ecosystem. And a lot of it also requires you to remove the noise. So reproducibility is critical. Chasing down the sources of variability for your benchmarks is important to know whether the thing that you change actually improves something or not. We do tricks like making sure that the benchmarks are running inside of EC2 cluster placement groups. So that removes network variability from the equation, removing proxies, availability zones, and so forth. Again, like remove variability so you can actually decide if the thing is better reliably or not. If the numbers aren't reproducible, don't publish them, don't share it. And I'm not talking about publish them on social media. Just don't even send it to your broader team if you can't reproduce the number. Sometimes it's really tempting to just be like, look, I hit this milestone. And the hardest part of clinical characterization is you got to be vocally self-critical. This used to be an Amazon leadership principle around you don't pretend your body odor smells of perfume. And this is what makes clinical characterization hard, because as soon as you start breaking your stack into the dimensions that are vulnerable in it, you start finding out the things that you did poorly. And it's hard. It's so much easier. Like you have all this hard time where you're like, oh, this sucks, this sucks, this sucks. And then you get like that one moment of, okay, I fixed it. And then you go back to, okay, this sucks, this sucks, this sucks. But this is how iteration and innovation happens. We're working on a new, like applying this lesson to Valkey Bench. We're working on a brand new software, open source software for Valkey Bench as well. This should be coming up very soon. But some of the problems in Valkey Bench today include the fact that it just runs as fast as it can. There isn't a way for it to say, hey, please target this particular throughput. You can't do get and set tests simultaneously on the same process. So we're working on the ability to have load patterns inside the benchmark, so you can have sinusoidal loads, and you can have connection bursts, and you can have multiple command types being tested. So you can say, hey, I need to test an 80-20 read-write ratio, or a 90-10, or a 10-90 read-write ratio, and just see how the software behaves. It's there to help people characterize when they're having outages, when their end users are complaining. They should be able to go to the benchmark tool and say, okay, I'm going to try to get this out there and reproduce it a little bit better. It's much, much harder right now to do that with the existing tool base. And everybody ends up building their own kind of scaffolding around it, and we're trying to get that to be a little bit better. The other thing that we want to build in it is we don't want to just tell the news. Like sometimes benchmarking tools will just tell you, okay, you did this many TPS at this latency. That's nice. What we want to see in here is deeper analysis, and the ability to say, okay, here's what, like we saw this many system calls, or hey, you're leaving packets unread on the network for this many units of time, and that might be adding to it, or here's how many retransmits you had. So yeah, you saw 200 millisecond latencies at P49s, but it's not really that you have P49 latencies, you're just having a retransmit, right? Like, so those types of things, we're trying to make that be better inside the benchmark tools for all the platform teams as well. The other concept to take away is coordinated emission, because when you have a benchmark tool that just slows down, it's not targeting a TPS, it makes your server look a lot better than it really is. Madelyn has this awesome video of you where you're saying most people measure latency wrong and people over index on latency. You gotta be talking about latency at a particular throughput with particular characterization, like average object sizes, the object distribution, and a target throughput. It doesn't really matter if you can hit a particular number. It's like I can drive my car downhill empty and I'll hit the MPG numbers that are advertised by the manufacturer, but that's not real world, right? So having these specific targets help you do better. It's hard. It is very hard. Like just having the conversation around what are the SLOs. How many of you have had conversations in your teams about, we got to go multi-region, but it's got to start with, well, what is your RPO, RTO, right? Like SLOs are really, really hard to talk about. Like convincing your teams to talk about SLOs is an uphill battle, but you have to convince them to do so. I don't want my stack to be faster. I want to hit this particular throughput, this particular error rate, and this latency for this distribution of object sizes. That is a very specifically characterized problem statement, and training your product teams to talk in that language and facilitating that conversation will help you make them happier as customers of the internal platform teams as well. Last thing for today is the ecosystem is much larger than Valkey. You're going to see people talking about Glide and the client drivers. So many of the problems in my journey of like root causing performance problems are on the client. It's whether it's, language specific, whether it's the library specific, and maybe the connection. There's all kinds of problems that happen on the client. So I encourage you to look end to end. The ecosystem also includes the proxies, Envoy and others, the modules that you can write in Valkey. We're going to talk about, Ron's going to talk about Valkey admin. And I think we're going to hear a little bit about Valkey operator in Aves's talk as well. So all that, you can help grow the community. It's not just by writing code and contributing. Maybe your company doesn't allow it. Maybe you're not a good coder, like I'm not a great coder, but there's other ways to help the community. Share the lessons that you're learning. Ask for features, because it sounds like you're being demanding when you say, I need this particular capability. But that insight and like the rationale as to why I need a particular capability, it really helps the people who are writing the code make sure that whatever innovation they're doing is grounded in real world workflows. So, I need Valkey to handle a specific error code, for instance, or throttle. So we're going to see a lot of feature requests in the talks as well. If you see stuff about Valkey, post it, repost it, interact with it. Today, there is an incentive where if you do post about Unlock Conf, because this is a gaming venue, we're doing a drawing for a Nintendo Switch. Yeah, we're doing a drawing for a Nintendo Switch. So if you take pictures about the conference and not just pictures, if you like share a particular, you'll be eligible with just pictures. But like if you share like, hey, I learned this particular tidbit, post that, put Unlock Conf on there, and you'll get to enter a drawing for a Nintendo Switch. And yeah, it's a nice system. And share your lessons, share your requirements, be vulnerable, be willing to talk about when you caused that outage that took down, your internal tools. It's okay. We're amongst friends here. And with that, I'm going to pass it on to Madelyn.